An introduction to approximating probability distributions. In a school of 600 pupils, 15% are left-handed. We can model the number of left-handed pupils using a binomial distribution. We want to calculate the probability that more than 100 pupils are left-handed. So we calculate the probability of 1 minus there being less than or equal to 100 left-handed pupils. But there are too many calculations here, and probability tables are not available. So instead of using the exact binomial distribution, we can try to approximate the probability by using an alternative probability distribution. And the options available can be summarized in the following triangle. So this triangle shows that if we start off with a problem in the binomial distribution, we could use a Poisson approximation to it, or we could use a normal approximation to it. But certain conditions need to be met. Or we may be starting off with a problem in the Poisson distribution, and we can use a normal approximation as long as certain conditions are met. To go from a binomial to a Poisson distribution, n has to be large, and the mean of the binomial, np, must be less than 5. If both of these conditions are met, we can solve a problem that started off in the binomial distribution and solve that using a Poisson distribution. As an example, if we have the following binomial distribution, the mean of this distribution is 4, n times p, which is less than 5, so this condition is met. N is large, so this condition is met. So we get the following Poisson distribution. So the Poisson distribution has a mean. We use the mean from the binomial, which is 100 times 0.04, which is 4. To go from a binomial to a normal distribution, the mean, n times p, must be more than 5, and n times q must also be more than 5. Both conditions need to be met first. As an example, if we have this binomial distribution, then n times p is 40, and that value is more than 5, so this condition is met. N times q, where q is the probability of failure, so 1 minus this probability, so n times q is also more than 5, so this condition is also met. And we end up with this normal distribution, where we have the mean for the normal distribution from the mean of the binomial, n times p, and the variance of the normal distribution from the variance of the binomial distribution. And the variance here is n times p times 1 minus p. So in this case it would be 80 times p times 1 minus p to give 20. To go from a Poisson distribution to a normal distribution, the value of lambda needs to be large. The larger the better. So if we have a Poisson distribution with a mean of 30, and in the Poisson distribution the mean and the variance are equal, then we get a normal distribution with a mean of 30 and a variance of 30, because the mean and variance for the Poisson are the same. When you approximate a discrete distribution, so that's binomial or Poisson, with a continuous distribution, that's the normal distribution, a continuity correction needs to be applied. it is needed to make the approximation as accurate as possible.